Welcome back, friends. Today we are going to start another part of our topic of electrochemistry ambapo tunasoma kuhusu electrode potential. Electrode potential. So tunachokisema nini? When an electrode is immersed in a solution containing its ions, electrolyte. Kwa mfano tukiwa tuna metal fulani M ambayo ni solid, then tumemweka kwenye solution ambayo ina ina M alafu N power yule pale ambaye ni aqueous. Yani kwa mfano tukiwa tuna zinc ambaye ni solid, then tumemweka kwenye solution ambayo ina zinc 2 positive nini aqueous. What will happen? Two things occur when an electrode, manake tayari tunakuwa tuna a solution yetu kama hivi, halafu tunakuwa tuna electrode yule pale tumfanyaje, tumemweka. Huyu ndio electrode. Let's say this is our electrode zinc, and then huku kwenye solution tuna zinc 2 positive ions. Zinc is just an example. Ndio maana general expression tunaweka metal, then kunaweka metal any positive ion. Unaona? Kwa sababu unajua metal they are positively charged. Two things happen. Kwanza, the electrode start to dissolve in the solution, giving its ions according to the equation below. Tunakuwa na metal ambayo ni solid, anaenda kutengeneza nani? Metal pale plus n electrons. Kwa kama huyu metal wetu labda ni zinc, maana yake itakuwa zinc solid kwenda kutengeneza ni zinc yule pale 2 positive plus 2 electrons. Hii ndio first reaction which will occur, ambayo electrode itakuwa inafanyaje? Ina dissolve. So hii reaction ni oxidation reaction because it involves the loss of electron. It is oxidation reaction. During this process, the electrostatic force of attraction between positive charge, yani cations, and the electrons released by the electrode in the ionization process, which are negative, prevent cations from going far away from the electrode. Kwa cations zinakuwa haziendi mbali ya electrode, so the cations get attracted very close to the electrode surface. Kwa hiyo hapa ni kwamba hii electrode inakuwa na negative, hii electrode inakuwa na negative charge, unaona? Inakuwa na negative charge. Halafu hii electrode inapokuwa na negative charge, huku kwenye solution kumbuka kuna positive charge. Hizi positive charge sasa haziwezi kaenda mbali, zinakaa pale pale jirani. Zinakaa pale pale jirani. So zinakuwa jirani kama hivi. Hizi positive charge zinakuwa haziendi mbali kwa sababu zinavutwa na negative charge zile za, lakini hazigusi ile electrode kabisa. Zinakuwa nearby lakini they don't touch the electrode itself. So they are nearby the electrode kama hivi. Hizi ndo cations zinakuwa hapo ziko jirani na nani? Na electrode, lakini hazigusi ile electrode. So there is electrostatic force of attraction between these cations and the electrons in the electrode. So hicho ni kitu cha kwanza. The second thing which can occur, the cations attracted to the electrode gain electrons from the electrode surface to form neutral atoms according to the equation below. Kwa hiyo wale katiani wanaweza gain electron kuform the neutral metal atom kama reaction hii hapa chini inavyoonyesha. So combining oxidation and reduction half equations shown above give the following reversible reaction. Inaonyesha reversible reaction kama hii hapa. Unaona? We have a metal gaining electron to form the neutral metal atom. Hii ni reversible reaction. Kwa hiyo inaweza ikawa favored either to the right or ikawa favored to the left depending on the reaction conditions. Eventually, the equilibrium is established and the electric double layer of oppositely charged species, positive and negative charges, is formed as shown in the figure below. Kwa hiyo kutakuwa kuna formation of what we call the electric double layer. Manake hapa tuna electric double layer hii hapa, ambako kwenye hii electric double layer hii hapa katikati, hii electric double layer, huku nje tuna positive charged ions, huku ndani tuna negatively charged ions. Half zinatengeneza the electric double layer. Kwa tunakuwa tuna electrode hii hapa, then huku tuna electrolytic solution au electrolyte. Huyu hapa ndo voltmeter wetu, tunatengeneza the electric double layer. Tunatengeneza the electric double layer kama inaonekana hapo kwenye diagram. So the electric electric double layer, EDL kwenye kifupi, is the layer created between negatively charged electrons on electrode, negative charged electrons on electrode surface and positively charged cations along the electrode surface. Along the electrode surface. Hazijatouch surface, they are along, zimejipanga. Along ni kama vile ambavyo unaweza kusema kwamba kuna njia halafu nyumba zimejipanga along the way, pembezoni mwa. Pembezoni ndio along. Kwa hiyo we have the cations arranged pembezoni mwa electrode, along the electrode, and then we have the anions on the surface. I mean the electrons, they are on the surface of the electrons, they are on the surface of the electrode, but the cations, they have been arranged along the electrode surface. So it can also be defined as the layer formed between the opposite charges, yani positively and negative charges on the electrode surface and the solution. On the electrode surface and the solution. Kwa sababu negative charge inakuwa kwenye electrode surface, while positive charge inakuwa kwenye solution. So the formation of the electric double layer, lead to the formation of a potential difference between the electrode and the solution containing its ions au electrolyte. Kwa hiyo kutakuwa kuna formation ya potential difference, yani tukiunganisha voltmeter hapo itasoma potential difference fulani. Unaona, electric double layer itasababisha tukiconnect one wire kwenye electrode na one wire kwenye solution, tutapata potential difference fulani kati ya electrode na solution. The generated potential difference is what we call electrode potential. Ndio ambacho tunakiita electrode ni potential. Yani electrode tumeiweka kwenye solution yake, tumepata umeme fulani, and that is the electrode potential, and it's denoted by the letter E. It is denoted by the letter E. That's why this topic is known as electrochemistry, kwa sababu the interaction between chemical reaction and the electrical energy. Kwa tunapata electrode potential denoted by the letter E. So by definition, electrode potential is the potential difference developed in the phase between electrode and electrolyte solution when an electrode of element is placed in a solution containing its ions. Kwa hiyo kinachotokea hapo ni kwamba tunapokuwa tumechukua electrode like this one, tumeweka kwenye solution containing its ions. Electrode tumeweka kwenye solution containing its ions. What happens is that kutakuwa kuna potential difference itakayokuwa developed between the solution and the electrode. Kutakuwa kuna potential difference ambayo itakuwa developed. So if the voltage or potential difference developed in the phase between electrode and the electrolyte solution when electrode of element is placed in solution containing its ions, This potential is a measure of energy per unit charge which is available from the oxidation reduction reaction. Energy per unit charge ambayo inakuwa available from the oxidation reduction reaction. Energy per unit charge ambayo inakuwa available katika ile oxidation reduction reaction. To derive the reaction, kwamba je, energy gani ilikuwa inatumika katika kudrive ile oxidation reduction reaction. It is measured in volts. Hiyo electrode potential inapimwa kwenye volts kama zilivyo potential nyingine. So electrode potential can also be defined as the potential difference between the electric double layer which is formed when an electrode is in contact with the solution containing its ions. So ni potential difference between the electric double layer. Na katika hizi electrode potential tuna potential za aina mbili. Tuna reduction potential pamoja na oxidation potential. Reduction potential is the tendency for a metal electrode in contact with solution of its ions to become positively charged with respect to the solution. Metal anakuwa positively charged with respect to the solution. Is the tendency of a metal electrode in contact with the solution of its ion to become positively charged with respect to the solution. Kwa hiyo reduction potential is summarized by this one. Unaona, metal ambayo ni positive charge una neutralize na huyo electron kwenda kupata yule pale solid. Hii ni summary ya reduction potential. Addition of electron ndio reduction. The potential difference associated with this reaction is reduction potential. while oxidation potential is the tendency of a metal in contact with a solution of its ion to become negatively charged. Maanake if you compare kati ya hii hapa na hii hapa ni negative, hii hapa ni positive. Kwa hapa metal electrode ina become positively charged with respect to the solution. Hapa metal electrode ina become negatively charged with respect to the solution. Kwa hii ni oxidation, the loss of electron is oxidation. Note that oxidation potential is equal to the magnitude and opposite in sign to the reduction potential. Kwa hiyo that is to say electrode potential ambayo ni oxidation inakuwa sawasawa na electrode potential ambayo ni reduction, lakini kinachotofautiana tu ni opposite in sign. Kwa kama huyu hapa ni positive, huyu hapa anakuwa ni negative, lakini zote zinakuwa zina magnitude ambayo inafanana, magnitude inafanana. So according to the IUPAC conventional, the term electrode potential means reduction potential. Inamaanisha nini? Reduction potential. Yani metal ina become positively charged with respect to the solution. Thus, the electrode potential are always given as reduction potential, and hence whenever we talk about electrode potential we always simply mean reduction potential. Kwa popote ukisikia tunasema electrode potential tunamaanisha reduction potential. Now let's discuss the factors affecting the electrode potential. Factors affecting electrode potential. There are four many factors which affect the electrode potential. Kwanza ni the nature of electrode, pili concentration of electrolyte, tatu temperature, na nne ni pressure of gaseous species. Tukianza na nature of electrode, two electrode cannot have the same standard electrode potential. Haziwezi zikawa zinafanana. Why? This is because no two electrode have exactly the same structure and the tendency to gain or to lose electron. Such properties are different for each electrode, or they are different for each metal. And if they are different for each metal, that means the tendency of this metal to gain and to lose electron will be different. And if their tendency to gain and to lose electron will be different, that means also his electrode is the cause na electrode potential ambayo ni tofauti. So when the solid electrode dissolves to form its ions in aqua solution, 3 steps or any changes are involved. Kwanza kuna atomization, pili kuna ionization, na tatu kuna hydration. Kwanza kuna atomization. Atomization, if you remember from thermochemistry, atomization involves converting solid electrode to its corresponding gaseous electrode from solid to gas. Hii inaitwa atomization. Now atomization process is an endothermic process. So the change in heat and atomization from metal solid to metal gas, it is positive because it requires energy from surrounding. But also we have ionization, ambayo ionization ni loss of electron, ambayo different metals they have different ionization energies. So this involves converting gaseous atom to its corresponding gaseous ion. This is also an endothermic process, and different metals they have different ionization energies. Hiyo ni endothermic process. Lakini finally is hydration, ambayo ile ion inakuwa hydrated kwenda kwenye hydrated form. So this involves dissolving gaseous ion in water to form aqueous ion. Gaseous ion in water, we dissolve it to get aqueous ion. We dissolve gaseous ion in water to form aqueous ion in solution. This is an exothermic process in a release energy. So the summation of atomization energy, ionization energy, and hydration energy determine the easiest or the ability of the solid electrode to dissolve in aqueous solution is per given forward reaction. Kwa hiyo extent ya electrode could dissolve inakuwa determined by the summation of atomization energy, ionization energy, and hydration energy. The total of these 3 energies ina determine nini extent of the dissolution of this electrode. So if the summation of these energies for the electrode is smaller yani more negative is smaller, more negative or less positive, more negative or less positive than another electrode, then the electrode potential of the first electrode will be smaller. Itakuwa smaller, yani more negative or less positive, and hence reverse reaction is more favored. Kwa hiyo kama hii electrode itakuwa ina zile summation ya energy ambayo ni ndogo, summation ya zile energy ni ndogo, electrode potential itakuwa ni ndogo, na hence katika hii reaction the reverse reaction is favored, yani backward reaction is more favored. But if the summation of these energies for one electrode is large, yani more positive or less negative than the other electrode, then the electrode potential or reduction potential will be large. The reduction potential will be large, yani more positive or less negative, more positive or less negative, and hence the forward reaction is more favored. Forward reaction itakuwa more favored katika hizo. Kwa hiyo hapo ni nature of electrode, that is the fact of nature of electrode. Factor ya pili ni concentration of electrolyte. Concentration of nini? Of electrolyte, ambayo inakuwa ni metal ions solution. Consider this equilibrium. Consider this equilibrium. From this equilibrium, kama hii hapa itakuwa kubwa, reaction itaenda wapi? Backward. Na ikienda backward, maana yake nini? Electrode potential itakuwa ndogo. Ikienda forward, electrode potential itakuwa kubwa. Increasing the concentration of metal shift the position of equilibrium to the left hand side. Thus decreasing the electrode potential, yani reduction potential, inakuwa nafanyaje? Inapungua. Reduction potential inakuwa inapungua. And increasing oxidation potential, inaongeza oxidation potential. Decreasing the effective concentration of this one shift the position of chemical equilibrium to the right. Ina shift equilibrium to the right, thus increasing the electrode potential. Itaongeza electrode potential. Factor tatu ni temperature. The electrode potential decreases with rise in temperature. Decreases with rise in temperature. The variation of electrode potential and temperature is given by the next equation, which will be discussed later. How the electrode potential decreases with the rise in temperature. Next equation to discuss huko mbele kwenye topic. Pressure for gaseous electrode. Pressure has no effect on the electrode which is in a solid state. Haina effect. Increasing in pressure of gaseous electrode increases its concentration. Hence, many gas molecules will dissolve in a solution of its ions to form ions and electrons. The equilibrium huyu hapa will shift to the forward, increasing the electrode potential, yani reduction potential of the electrode. Kwa hiyo kiufupi hizi ndizo factors ambazo zina affect electrode potential. Hizi ndizo factors. In the coming session we'll move to another part discussing about the standard electrode potential. Standard electrode potential. Thank you, and later wish you nice studies.